My dear friends, today in this session we are going to discuss a small problem on work energy principle. End of this particular session, student will be able to solve the problems on work energy principle. This is the problem that a small block starts from a rest, means the initial velocity is 0 at a point A and slides down at an inclined plane as shown in a figure. So I am preparing you a figure now. What distance along the horizontal plane will it travel before coming to rest? So you may identify the distance, that is S. Then one more thing, coefficient of a kinetic friction between the block and the plane they have mentioned here, that is 0.3. Assume initial velocity with which it starts to move along BC is of the same magnitude in a sliding from A to B. Small block is there, it moves in this direction and it slides in a further direction. So here the block is present here. This is the toe A, this is B, and one more point C is present. So you may consider like this. Further, you may consider this is near about 3 meter, this is 4 meter, so the remaining you may consider directly it's 5 meter. Theta, you may consider here that the value of theta is 36.86 degrees there. The value of mu they have given, that is 0.3. Horizontal distance you may calculate. Then first condition, the block is present here, it slides from A to B. At that particular moment you may calculate the velocity at the final velocity at point B. Initially it's 0. Now the same block moves from B to C, so at that particular time we are calculating the distances. Now here the weight of this particular block they are not given. So we are considering here two parts separately. First one, the block is present exactly A to B position is there, and then we are going to apply the energy principle. So if I consider the first case, so the figures or the schematic diagram, it looks like in this way. This is the block, means we are considering motion of a block from A to B. So motion of a block, so we are considering here A to B is there. So the normal reaction is present, this is your R1, weight is present, so two components are present here. Weight is always present in a vertical downward direction, W. So here W cos theta and W sin theta, two terms are present, W sin theta and W cos theta is there. Further, the block moves in a downward direction, so the frictional force is present in upward direction. This is your F1, right? So the nature of the block, it moves in a downward direction, so the frictional force is present in upward direction. Now further we are resolving this particular block or motion of your block in a first normal to the plane and next parallel to the plane. Means first of all we are considering summation v is equal to 0, that is normal to the plane, normal to the plane. So here first is r1 is equal to w cos theta is there. So you may consider r is equal to w cos theta, r or r1, what it may be. So we don't know the value of w, but we know the value of theta, that is 0, 36.86. So you may put r is equal to that w you may consider as it is, and you may put the value of theta, so you will get the answers. Second one thing, here it's come 0.8 w is there. Now you know the value, that is mu 0.3, so you may calculate the f1. So f1 is equal to mu into r1. So the value of mu is 0.3 into r1 is 0.8, w is there. So mu is equal to 0.24 w is there. So this is the first frictional force regarding the block number 1. Now here frictional force we have calculated according to the friction law. Here you have calculated the normal reactions, that is R. Now we are going to apply the principle. Before that, resolving the forces parallel to the plane and energy principle. We are going to apply, we are resolving the forces parallel to the plane and you may apply the energy principle. So whenever you are applying the energy principle, so you may observe here F into S is equal to m by 2 v square minus u square. Initial velocity is 0, final velocity you may calculate here. F is nothing but all horizontal forces for this particular block. How many horizontal forces are present? One is w sin theta, right hand side positive, and f1 left hand side negative. The value of S is there. That value of S you may put here or you may calculate here. So the value of S already you have calculated here, that is 5 meter is there. So let's you observe minus F plus W sin theta into S W m by 2. So the weight of this particular block W is there, we don't know, so W 9.81 into 2, that is v square minus 0. So put the value of f1, already you have calculated 0.24 w is there, 0.24 w. Now further minus plus w sin theta, so w sin theta is 0.59 w into your S is equal to w divided by 19.62 v square. So you may take the common, that is w, 1.75 w is there, and here so this is S is nothing but 5, you may multiply here and then you calculate, and here you may consider that is w divided by 19.62 v square is there. W get cancelled and you will get the value of V, that is 5.9 meter per second square. So you have calculated here one term, that is 5.9 meter per second square is there. Now the second term is present, that second term, that is we are consider motion of a block from B to C. So whenever you are considering from B to C, So you may observe here the position of the block is like this. Block is moving in this direction, so the frictional force F2, weight is present downward, normal reaction is upward, that's all. So here you may calculate first, that is summation V is equal to 0, so R is equal to W. Now according to the friction law, you may calculate the frictional force F is equal to mu into R. 0.3 into W, that is nothing but your F is there. So similarly you may apply the energy principle. Energy principle, all of you know, F into S m by 2 V square minus U square. So here weight, horizontal forces only one, that is F negative, okay, according to the figure, into S, that is unknown, you may calculate m by 2, that is W divided by 9.8, you may consider, into 2. And here in the first case you may observe the picture here, block starts from here and comes here. So initial velocity 0, final is here. So final velocity, that is nothing but for A to B motion, V is there. That is nothing but the initial velocity for B to C, that particular block move from B to C. So at that particular time, whatever the initial velocity is there, that initial velocity is nothing but final velocity of the motion of the block from A to B is there. And it comes, already we have calculated here, 5.9 is there. So you may consider here that particular 5.9 square. Now you may put the value, and 0.3 W is there, so you may consider here minus 0.3 W into S is equal to W divided by 9.81 into 2 minus 5.9 square. So minus you may sacrifice that particular values here. So 0.3 W into S is equal to W divided by 19.62 5.94 square. Now we want the value of S. Do the calculation. W get cancel, only S is remain there. So the value of S is 5.9 meter is there. So steps, once again I will highlight you the steps. This is the first, the problem statement, then the figure. In that we have considered first block. So we have calculated the reactions, frictional force. Further we are applying the energy principle. We have calculated the value, that initial and final velocity we have calculated. The final velocity for first block, we have considered the initial velocity for next block, and here also we have calculated the answers, and the distance is 5.9 meter is there. So these are the references that I have referred for preparation of the videos. Thank you.